Welcome to this explainer. If you've ever wondered how modern apps juggle massive amounts of data without dropping a single detail, you're in exactly the right place. We're going to completely demystify relational database management systems, or RDBMS, and break down the core concepts and terminology together.
Here's how we're breaking it down today. We'll start with the foundation of RDBMS, move on to unlocking data with keys, look at building database relationships, learn the formal language of databases, and finally, we'll tackle degree versus cardinality.
All right, let's jump straight into part one, the foundation of RDBMS. So what actually is it? RDBMS stands for Relational Database Management System. And really, it's exactly what it sounds like, a highly systematic way to manage collections of interrelated data. Instead of digging through some massive, messy text file, an RDBMS organizes everything so that its relationships to other pieces of information stay perfectly intact and, most importantly, easy to access. Now, the absolute core building block of this entire system is the table. A table is your basic data storage unit in a relational database, and it's made up entirely of rows and columns. You can think of it as the blank canvas where all of our data organization actually begins.
To see this in action, just take a look at this student table. We've got our data neatly sorted into a grid. There are headers across the top, roll number, name, and class, and right underneath we've got specific, structured details for students named Rahul and Priya. Let's break that grid down into its two main parts. Fields are the vertical columns, right? They represent one highly specific type of information, like a name field or a class field. Records, on the flip side, are the horizontal rows. A single record contains all the combined information about one particular person or item. So, looking at our example, everything belonging to Rahul, his roll number, his name, his class, that all bundles together to make one single, complete record.
Moving right along to part two, unlocking data with keys.
Here's a common problem. How do we avoid confusing two students who happen to have the exact same name? Well, we use a key. A key ensures we can perfectly identify specific records without any mix-ups. It can be a single column or even a combination of columns that lets us pick out a specific row. So if we have two Rahuls, we just use a key, like their unique roll number, to tell them apart.
Now, there are two crucial types of keys you absolutely need to know. First up is the primary key. This belongs uniquely to its own table and is used to uniquely identify each row. It's the ultimate identifier. But databases don't just sit there in isolation. That's where the foreign key steps in. A foreign key is a field in one table that refers directly to the primary key of a completely different table. It literally acts as a bridge between them.
Which brings us to a really important question. To test what we just covered, what actually connects two related tables? As you might have guessed, it's that foreign key. Whenever two tables need to talk to each other, the foreign key steps right up to make that connection happen.
And that leads us perfectly into part three, building database relationships.
Let's see how these keys build some truly powerful networks. By using those foreign keys, we establish what we call relationships. A relationship links data from individual tables together to make the entire database exponentially more useful. In fact, a relationship actively exists the exact second one table has a foreign key referring to the primary key of another.
There are three main ways these relationships play out. You've got your one-to-one relationship where a single record in one table matches up with exactly one record in another. Then there's the one-to-many relationship where one record connects to multiple others. And finally, you have the wildly complex many-to-many relationship. These three structures are the absolute blueprint for how all data flows and connects within our system.
All right, part four, the language of databases.
If you want to sound like a true database expert, you have to upgrade your vocabulary. Instead of just saying column and row, we use formal relational terminology. An attribute is the formal term for a column. It represents a specific characteristic for the stored data. And a tuple, that's spelled T-U-P-L-E, is a formal, fancy term for a row of data or a record.
We also need to talk about the domain. You can think of the domain as the strict, non-negotiable rulebook that dictates exactly what kind of values are allowed inside a specific attribute. For example, if you have a roll_number column, its domain is strictly integer values. You absolutely cannot put a letter or a special character in there because it violates the domain. It's built-in quality control.
And finally, part five, degree versus cardinality.
Take a quick look at this slightly expanded student table. We've swapped out class for marks, and we've added a brand new student named Amit.
Let's see how this table actually measures up.
Here are the metrics you need. The degree of a relation is simply the number of attributes, or columns, in the table. On the other hand, the cardinality of a relation counts the number of tuples, or rows, in the table. People get these two mixed up all the time, but keeping them straight is incredibly crucial for database management.
Because it's so easy to confuse them, I want you to burn this little mental shortcut into your brain right now. Degree equals columns. Cardinality equals rows. One more time for the folks in the back. Degree is columns, cardinality is rows.
So applying that to our student table example with Rahul, Priya, and Amit, we have exactly 3 columns, roll_no, name, and marks. And we also have exactly 3 rows of student data. That means both our degree and our cardinality for this specific table are exactly 3.
To wrap this whole thing up, we've gone on quite a journey today. We started with the basic table, field, and record. We uncovered how primary and foreign keys link everything together, upgraded our vocabulary to attributes and domains, and finally learned to measure our tables using degree and cardinality. That right there is the absolute core foundation of relational databases.
But all of this leaves us with an incredibly fascinating question for our next explainer. We know how to organize and connect data in theory, but how do these perfectly neat little grids handle the amazingly messy, many-to-many relationships of the real world? Seriously, think about students enrolled in dozens of courses or a massive online store with millions of customers buying hundreds of different products. How does the database keep from just completely breaking apart? Well, we're going to tackle exactly how those complex relationships come alive next time. Thanks so much for joining me on this explainer, and keep learning.